This is a video looking at surds, and let's just do a very quick recap. So, for example, if we have the square root of 9, we can write that as 3 because 3 multiplied by 3 is 9. And we call that the principal square root. But of course, also negative 3 multiplied by negative 3 is 9. So we can insert this. And the root of 9 is not a surd because we can work it out, plus or minus 3. However, the root of 5 is a surd, the root of 3 is a surd, and every square root of a non-square number is a surd. And what we mean by a square number is 1, 4, 9, 16, n squared. Okay, so that's a very brief introduction to what a surd is, and let's more formally look at square roots. So a square root of a number x is the number y such that y squared is equal to x. And we can see that. Let's have a look at a square with area, say 5 centimeters. Well, the area, side length rather, let's say the area is 25 centimeters squared. Well, the square root of 25 is just going to be one side length, which is going to be 5. So for x that is greater than or equal to 0 has a unique non-negative square root called the principal square root. So for example, square root of 1, square root of 4, square root of 9, square root of 25, square root of 1000 has a principal square root of 1, 2, 3, 5, and 100. But of course, from the previous example, we know that the negatives of those numbers also give the number at the bottom. And let's define this as a radicand, and this is referred to as a radical. Now, not all radicals are surds, as we've just shown. So sometimes students use radicals and surds interchangeably, and strictly that isn't correct. A surd is quite different from a radical. A radical refers to the structure of a square root, whereas a surd is a radical that can't be simplified. Okay, so let's move on. Let's use a different color. So the square root of 4 is plus or minus 2 because 2 multiplied by 2 is 4, and also negative 2 multiplied by negative 2 is also 4. For x that is less than 0, if we have the square root of x, the result cannot be computed using real numbers. The result is a complex number. So that gives rise to the fact that when we're dealing with surds, we're dealing with non-negative numbers. That is, numbers that are greater than or equal to 0. So that's quite an important fact. So for any rules that we use for surds, so say for instance, we consider values for a that are greater than or equal to 0. Okay, so let's get a formal definition. A surd is a number such that the square root of that number n cannot be simplified. Surds are a way of writing an irrational number exactly. So the root of 2, the root of 5, the root of 7, so on, give irrational numbers, that is, they are non-terminating, non-repeating decimals. So for example, on your calculator, if you type in the square root of 2, you get an approximation, 1.4142135662. That is an approximate value. That's a 4. Now, you might be thinking that this is pretty accurate here. This is pretty accurate. However, when you're dealing with very large numbers, these can make a significant difference. Hence, it is preferable to use surds. Okay, so I'll just give you some time to absorb. What I just taught, and let's have a look at some rules. Okay, so rules of surds. Okay, so the first are merely definitions. So the root of a, where a is greater than or equal to 0, is called the principal. root. Where a is greater than or equal to 0 is called the negative square root. Okay, we can use the distributive property in maths, given that a is greater than or equal to 0 and b is greater than or equal to 0. So this is sometimes referred to as the product rule, where the root of a multiplied by the root of b can be simplified as ab. Then there's the quotient rule, where this can be written as this. And let's put the power rule in, where we have is the same as the root of a, or we can write this as a to the n over 2. I'm going to put this in a little box here. The root of a can be written as in exponent form, a to the half. So let's give some examples of these. Let's give some examples. I'm going to put the examples in, let's use orange. And let's use bold. Okay, so for the product rule, if we have the root of 2 multiplied by the root of 3, this can be written as the root of 6. For the quotient rule, this is the same as doing the root of 12 over the root of 4. The root of 12 can be simplified to 4 root 3. We can cancel that and we simply get the root of 3. The power rule, okay, let's consider 3 squared square root. Well, this is 3 squared multiplied by a half, which is just 3 to the 1. And finally, you may wish to pause the video to write these down. Finally, there's something called rationalizing a surd. And mathematicians do not like to leave radicals on the bottom. Rationalizing. So for instance, if we get the root of 2, root of 3, 3 over root 3, or even something like this, we don't like to leave a surd on the denominator because for a variety of reasons it makes it difficult to compute. So for example, if we were to evaluate this, we would need to write this as a huge decimal and then divide into 1. But we can use some algebra and we can rationalize this denominator by multiplying numerator and denominator by 1 effectively. Root 2 over root 2 is 1. So 1 times root 2 is root 2. Now root 2 multiplied by root 2 is just 2. And we can write that as a rule here. The root of a multiplied by the root of a is a. And we can show that. One way to show it is to write the radical sign as an exponent of half, and we can use our rules of indices. Let's get rid of this. Show that that's 1. And that's easily shown using numbers. So for instance, the root of 3 multiplied by the root of 3 is the root of 9, which is just 3. Okay, so let's have a go at rationalising this. We multiply numerator and denominator by 3 to get root of 3 over 3. Do the same here to get 3 root 3 over 3. The 3's cancel and we're just left with root 3. Okay, so I'm going to leave the last one for you to do. Pause the video. Okay, so hopefully you've done that now. We multiply numerator and denominator by root 3 to get root 6 over 3. Okay, so in general, the general case, if we have a is greater than 0 and b is greater than 0, and we have a over root b, we can multiply numerator and denominator by root b to get a root b all over b. Now, before we move on, let's have a look at some misconceptions. Now, there's a lot of misconceptions concerning surds, and I'm going to give this a title of misconceptions. And these are quite important because they're very common mistakes. Misconceptions. One really common misconception is if we have the root of 12 over 3 is the same as the root of 4, which is 2. It's just taking the principal square root. You can only use the quotient rule for dividing indices or surds if they are both to the same power on, in this case, both roots. So the square root of 12 divided by the square root of 3 is the square root of 4, which is 2. But you can't do that here because the denominator is not a square root. The same goes for the product here. That is not equal to the square root of 6. That is simply equal to 2 root 3. Another common misconception is that the root of 2 plus the root of 3 is the root of 5. That is definitely a no-no. The same goes for the root of 12 minus the root of 11 is the root of 1. That's a big no-no. Okay, so let's try some problems. Okay, so the first set of problems are just to simplify, and I'm going to do an example at the side here. Let's do green. Okay, let's simplify the square root of 150. Now the idea when we're simplifying these is to split the number up into a product of a square number and another integer. So we can write this as a root b. Well, there's a few ways we can do this, but one of the easiest ways is to find the largest square root product. And that's going to be 25. 25 multiplied by 4 is 100, multiplied by 5 is 125, and multiplied by 6 gives 150. So we can rewrite that then as 25 multiplied by 6, and then write it as 5 root 6. And we can check that on our calculators. 25 times 6, and we can take the square root of 150, subtract 5 root 6, and if we get 0, we have done our simplification correctly. Let's do a example here. Let's simplify, or I don't know, 2 cubed and square root. So we can work this out straight away. 2 cubed is 8, and then we can simplify this as the root of 4 multiplied by the root of 2, which is just simply 2 root 2. Pause the video and have a go at simplifying these questions. So hopefully you've done that now. So let's go over the answers. I'm going to do these quite quickly. If I can get this pen to work. Okay, so let's do red. So we can't simplify this any further. So just the root of 3. Okay, so the root of 4 multiplied by the root of 2, 2 root 2. This just gives 4. 25 times 2, which is 5 root 2. Here we're going to get 16 multiplied by 5, which is 4 root 5. Okay, so this just gives 9, which is 3. That gives 4 squared, which is 16. That gives 2 to the 3, which is 2 times 2 times 2, which is 8. This gives 8 squared, which is 8 multiplied by 8, which is just 8. Okay, so mark your work, and then we'll have a look at some more questions. Okay, so here we have some questions. Some of them are straightforward, some of them a little bit tricksy-dixy. Pause the video and see how many you can do. So hopefully you've done that now. So I'm just going to insert an equal sign. Root of 3, 12 can be written as 4 multiplied by 3. This gives the root of 3 plus 2 root of 3, and here we have 3 root 3. So this simplifies as 2 root 3, and that simplifies as 4. We can't simplify that any further. This simplifies as the root of 4 and the root of 10 minus the root of 4 over the root of 5. That is 2 root 10 minus 2 root 5. We can't simplify that any further as these are different. Okay, so here we use the rule, the product rule, in that the root of a multiplied the root of b is the root of ab. The quotient rule is simply this. So that is the root of 6. So that is the root of 6 multiplied by 2, which is 2 root 6. So this just simply removes the radical sign. So this just gives 2 plus 3, which is the root of 5, which is the surd. Okay, so we can just divide straight out there to get the root of 3. Here we can just divide straight out to get the root of 5. And here we need to do some simplification. Now, we can either do this, the root of 24 over the root of 6, which is the root of 4, which is just simply 2. Or we can use some algebra. We can use some algebra and say, well, the root of 2 over the root of 2 is the same as the root of 12 over the root of 3. Well, that just gives 1 multiplied by the root of 4, which is just simply 2. Okay, so let's have a look at some more questions. Okay, rationalize by removing radicals in the denominator. Now let's do a little recap. So for a greater than 0 and b greater than 0, if we have a over root b, we multiply numerator and denominator by 1. This here is just simply equal to 1. So we're not changing the quotient or the fraction at all. So we can distribute this a root b, and let's do ab over the root of ab. Well, we simply multiply numerator and denominator again. So we get AB root AB over AB, which just leaves us with AB. So don't fall into the trap of doing this. Root AB multiplied by AB is A squared B squared. That is wrong. That's very, very wrong, because we can't multiply these. Why? Because there's no square root here. Okay, so let's have a look at some examples then. Let's rationalize 1 over the root of 7, 7 over the root of 5, and 2 root root 3 over root 6. So have a go at rationalizing those, and then we will do the exercise. So pause the video. So hopefully you've done that now, and I'm going to just draw a line and do this up here. So 1 over the root of 7. Well, we multiply numerator and denominator by root 7 over 7, which is the same as 1. So we get root 7 over 7. 7 over root 5. We multiply numerator and denominator by root 5 to get 7 root 5 over 5. And the same with 2 root 3 over root 6. We multiply numerator and denominator by root 6 to get 2 root 3 times root 6 all over 6. 2 times 3 6s at 18 all over 6. We can simplify that fraction to get 1 over 3. And don't forget 18 can be simplified as the root of 9 multiplied by the root of 3. That gives 3 root 3 over 3, which just gives root 3. Okay, so copy those examples down, see if you understand them, and then have a go at the exercise above. Pause the video. Okay, so hopefully you've done that now. So rationalising is a really important skill in maths, because lots of computations leave radicals on the numerator, and mathematicians don't like radicals on the numerator because it makes computation much more difficult. So you would never see an answer in the back of a textbook 1 over root 2. They'd always rationalise the denominator. Okay, so hopefully you've done that now. So let's write that down again. So we multiply numerator and denominator by root 2 to get root 2 over 2. The same for this one. We multiply numerator and denominator by root 3 to get root 6 over 3. We can simplify first here. 2 root 3 over root 4 root 3, which gives 2 root 3 over 2 root 3, and that simplifies to 1. So not really a rationalising question, more a simplification question. Now let's see if we can get the same answer by multiplying by root 12. If we don't, we're in trouble. So we get 2 multiplied by root 3 root 12 all over 12. That is 2 root 36 over 12. the square root of 36 is 6, so 2 times 6, which is what we had. Okay, so this needs special consideration, the last one. Recall if we have A over B multiplied by C over D, that's just AC over BD. Now, if we have AB divided by C over D, remember that we need to invert or flip the second fraction to give AD over BC. These are really important identities which you should know already, but if you don't, please copy them down. Okay, so hopefully you've done the last question. So let's rewrite this using the multiplication sign. We invert the second fraction, and we can rewrite this as the root of A over the root of A multiplied by the root of C over the root of B. This just simply gives 1, so we are left with the root of C, that is the root of 6, not C, the root of C over the root of B. So we rationalize by multiplying numerator and denominator by root B to give root C over root B all over B, and we can rewrite that as CB over B. Okay, so I think that's a pretty good introduction to Surds. We've covered a lot there. Now, see if you can do some more complicated questions by yourself. Some more complicated ones might be something like this. Root of 2 plus the root of 3 squared. You might be asked to rationalize. Something like that. You may be asked to simplify, something like this. And so on and so forth. Surds are a really useful tool in maths, in particular the rules of Surds, because they allow us to simplify some important results. So there's no way you can get away from Surds in maths because they appear throughout. Anyway, I hope you enjoyed this video and carry on your hard work in maths.